So this is going to be the same exact thing that we just did, except there will be a hole through them. So it's still pi r squared, but we kind of factor the pi out. You just have pi that sits out front. And do you see how it's r squared minus r squared? One of them's capital and one of them's lowercase. This is actually one of the times I'm sort of on board with the capital and lowercase. I normally don't like that. I'm like, couldn't you have picked a different letter? But I kind of like it because this is the bigger circle minus the smaller circle. Do you see that? So it's like you're taking the, here, I'll draw you a picture. It's like you're taking the whole thing and subtracting out the insides so that you can get the area of this part. And it's called the washer method because like at the hardware store, those are your washers, but everyone calls it the donut method. So anyway, same thing that we just did, except there's two circles. And we'll just put these ones in the calculator. Usually on the AP exam, these are the ones that are set up but do not evaluate. And I'll explain to you how the points typically work once we do one of them. So if I find the volume of the solid generated by revolution, all right, by the parabolas, y equals x squared, just a regular old parabola. So just go ahead and draw yourself a parabola that hasn't been transformed at all. So like that. Now the other one's written a little funny. It's y squared equals 8x. So to get y by itself, we would have to square root. So you're going to have y equals square root of 8x. Technically, it would be plus and minus because you're going to get a sideways parabola. I'm not going to write the plus minus, but we will draw it over here so that you can see what I'm talking about. So if you want to make a table of values, what do you want to try and plug in for x? What's the easiest number? Oh, 0, and then 2 would be the next one, yeah. So if you plug in 0, you're just going to get 0. If you plug in 2, you get square root of 16, which is 4, and you're actually also going to get negative 4. I should have put the plus minus in there, but you'll see what I mean in a second. So 0, 0, 2, 4, and 2, negative 4. So it's a sideways parabola. It's going to look like that. So you have two parabolas, one right side up and one sideways. We're going to erase a lot of that. So the area surrounded by both of them or enclosed by both of them is this little like leaf kind of shape. And then you can erase all your tails from around the outside of it. So that's the area that we're spinning, revolution. What are we spinning around? Because that dictates dx or dy. Yeah, the x-axis. So it's going to be a dx problem. You can draw yourself a ghost shape down here below the x-axis. And you're going to have to really use your imagination here. I'm going to attempt to draw it, but as a heads up, it's not going to look that great. Okay, you're going to have to imagine what's going on. Your outside circle goes all the way to the edges. Do you see how I drew that all the way out to the edges? And then your inner circle just touches the inside. So if you can imagine that it's circular, it would be like a bowl that you could actually put stuff in because there's a whole, it's not solid the whole way through. Do you get what I'm saying? I always say this one would be sort of like a fancy candy dish because the inside of the dish, do you see how it's shaped like this? The inside of the dish would be like this the whole way around. So kind of like a, can you imagine like a fancy glass candy dish that's like shaped a little bit weird? Are you seeing it? Okay. So it's going to be dx, set it up blank. I'm zoomed in kind of far here. Let me zoom out. So it's going to be pi. It's pi r squared minus pi r squared, but we factor the pi out. It's GCF. We GCF'd the pi out front. So it's going to be r squared minus r squared dx. Set it up blank. Do the framework. I'll explain why in a second, but you should always do that. Boundaries need to be x values. So that, look at your x-axis, that would be where to where. Yeah, 0 to 2. And I will attempt to show you this here. The outside radius goes all the way to the edge. So that is this graph. Do you see the one I'm highlighting there? which one is that? That's the sideways one. So that's your square root of 8x. And then your inside radius goes to this one, which is the x squared. Now you could do that by hand, but I'm going to just put it in the calculator. And listen, this is typically how they do the points on the AP exam. They'll say set up, but do not evaluate. If you write pi and get your boundaries correct, that's a point. And then it's a point for this one squared, and it's a point for this one squared. So it's typically 3 points, and you don't even do anything. Okay, you just set it up. It's usually on there too. All right, I'm going to put it in the calculator just because that's what Delta Math does. So again, when I'm typing this, I am not performing for you. I want you to watch, make sure I don't do anything wrong. Because if I type it wrong, it's the wrong answer. All right. I int, what are we, 0 to 2? Am I good so far? All right, minus parentheses squared. I guess I could have written next to the fourth, huh? Oh well. Oops. There you go. 30.159. Does that look right? Make sure I didn't mess anything up there. Okay, let's try it again. The volume of the solid generated by revolving revolutions. The semicircular region bounded by this. Let's make a table of values, but it is going to be a semicircle, they just told us. So it's kind of nice that they tell you what shape you're going to end up with. I'm going to plug in for y and get x. Let's start with 0. If you plug in 0 for y, you're going to get square root of 4, which is 2. So right here, 2, 0. Oops. Really zoomed in. Let me zoom out a little bit more. So this point right here. All right, I don't want to plug in 1. That would give me square root of 3, which without a calculator, I don't know what that is. So what could I plug in instead? Yeah, actually 3 wouldn't be a bad idea. Oh no, because you have to square it. So then you'd get a square root of a negative. Let's do 2 and negative 2. They're both going to give the same thing. So if you even want to just write plus minus 2, you can do that. 2 or negative 2 squared before 4 minus 4 is 0. I should have written those on the same line. I don't know why I did that. But anyway, it's going to be this semicircle right here. They said it was going to be a semicircle, so that makes sense. And the y-axis. So this is your shape here. And we are spinning it or revolving around what line? Go ahead and read in there. Yeah, x equals -1. So I'm going to dot that in. It's right here. And then we're going to decide if this is dx or dy. So it's like you took which axis and scooched it over. The y. Okay, so dy. That is the best that has ever gone. That's usually such a struggle. You guys are getting it. It's like you took the y-axis and just scooched it. Maybe I'm explaining it better than I have in years past. All right, so draw your ghost shape on the other side. You're just reflecting this over that dotted line. And let's see if we can imagine what this would look like. Your outside circle goes all the way to the edges. This is your inside circle. It would be like a basketball that someone punched a hole through. Or like a bead for a necklace with a hole through it so that you can put the string on it. What did you say it would be?
Oh, no, I thought it was my call.
Yeah, or sort of like a cue ball, like a pool ball, a billiards ball, you know what I'm talking about? With a hole through, except it's not quite a sphere. Do you see how it's like a little bit elongated? But are you imagining a solid thing with a hole through? That's what's going on. All right, pi r squared minus r squared dy. Set it up blank so that you have the framework. Your boundaries need to be y values. So look at your y-axis. That would be where to where? Yep, -2 to 2. And then I'll need you to watch me point to this. It's going to be right minus left. So all the way to the edge. This is the right graph. Which one is that? Yeah, the semicircle, this weird square root thing. And my radius goes all the way to the axis of revolution, which is where? -1. So it's going to look like this. Square root of blah, blah, blah. That's your right graph minus -1. It's right minus left. It's this one. If you want to watch me point to it again, it's this one minus your axis. You have to go all the way to the axis of revolution. All right, your inside radius. Usually instead of doing right minus left, I just try to get everybody to see it. Do you see how it's just from here to here? How far is that? From there to there. I usually try to get everybody to just sort of make that leap because it's not very complicated. If it's from there to there, like, do you get that that's just 1 unit? 1, okay. I'm not gonna bother putting that in the calculator. You guys would all just sit there and watch me put it in the calculator. Do you understand how to use the calculator? Good, let's keep going. It's the setup that's the most important part. Oh, I remembered that I did this. We're gonna skip A for the sake of time, but we'll do B, C, and D. We're going to draw this and then just copy it over for the other ones so we can reuse our work. So this is going to be a parabola, except instead of right side up, going to be sideways. All right, so draw yourself a sideways parabola, but just like a regular old parabola. Like it's not stretched or shrunk or moved around or anything. Got 15 minutes. We'll definitely be able to finish this. All right, and then the x-axis and x equals 4. So here's your x-axis, and then x equals 4 is this vertical line here at 4. So this is your shape. And then just go ahead and copy that over for the other two grids. Because I was just trying to make it so that we could reuse our work. I made the grids slightly different. I'm making them big enough that you can fit everything you need to fit on there. At least I think I made them big enough. I hope I did. Yeah. Go me. So I'm not changing the shape, I'm just changing the axis of revolution. So for this one, we are spinning around the y-axis, so it's going to be dy. So this is your axis of revolution. You can draw your ghost shape on the other side, just, reflect it. And again, I'll attempt to draw this, but you're going to have an imagination because it's not going to be perfect. Your outside circle goes all the way to the edges. So do you see how that goes all the way to the edge? And then the inside one just touches the inside graph. So imagine what this would look like. Kind of like an outdoor swimming pool, above ground swimming pools. You know how the edge around the outside is flat? Like, do you see how this would be flat there? Mm-hmm. So imagine an outdoor swimming pool, but the inside is like this. So you could swim in it, but you would fall to the center. Do you get what I'm saying? Okay, good. You're imagining it. Nice. So we're going to do pi r squared minus r squared dy. Your boundaries need to be y values. So look at your y-axis. It would be from where to where. So good. You guys are great at those boundaries too. Nice job. Now the outer one, again, instead of trying to do right minus left, I just try to get everybody to make this leap. Because this is flat, it's the same the whole way around. How far out is it? It's just a number. 4. Do you see how that's 4 units? Just from there to there is 4. It's literally just the number 4. And the inside one, this is your inside radius, is this graph here. So which one is that? Go back to the problem. What is your equation? Is y squared, right? for the sake of time, you could put that in the calculator, right? GeltMath's going to have you just set it up, put it in the calculator. This is set it up, put it in the calculator, set it up, put it in the calculator. The setup is what is the most important part. All right, next one. We're going to spin or revolve around the line x equals 6. So this is your axis of revolution. It's like you took which axis and just scooched it over. You're good. So this is going to be also dy. It's like I took the y-axis and just moved it over a little bit. So reflect your ghost shape over there, and I left you enough space. It's gonna look something like that. Your outside circle goes all the way to the edges. And then your inside circle, which is the hole punched through, just goes to right there. So this would be like a pitcher's mound, but like a hole through the center. So like where the pitcher is standing, there would be like a ditch. Do you get what I'm saying? Like a hole punched out. It's like this, it's round, like a mounded thing. Or do you know, oh, this would be a good analogy. Do you ever see trees with all the mulch around them? It's like the dome of mulch, but if you took the tree out, there's the hole. And oh, okay, there, that's a better one. I like that, but I'm always coming up with better things. Welcome to my internal monologue. All right, so pi r squared minus r squared dy. That's a really good way to think of it. Imagine that mound of mulch, but like you took the tree out. So there's a hole through the center of it. So what are our boundaries? They need to be y. Yeah, same as the one we just did, right? 0 to 2, because I didn't change the original graphs. All right, now watch me point to it. We are going to kind of have to do right minus left here. I don't have a, another way to do this. This is your radius that goes all the way to the edge. So your right graph is the axis of revolution, which is what? 6. This one is 6. That's your right graph, minus your left one, which is this one. We want to go all the way from the axis of revolution out to the edge. So it's going to be 6 minus y squared. Good. It's right minus left. And then the inside one, because this is flat, it's just how far, like how many units is that? It's just a number. Do you see how it's just literally 2 from there to there? So right minus left. Now I usually get asked, and I bet half of you are thinking this, and if you are, then good, because this is a good question. Why did she do 6 minus this graph? Why didn't she do that graph minus 6? That would also be right minus left. You have to remember this isn't actually here. It's the ghost shape. Do you get what I'm saying? I drew it in so we could visualize it, but it's not really there. Don't use the ghost shape to do right minus left. Okay? Last one. The line y equals 2. That's going to be this right here. So will this be dx or dy? Yeah, good. It's like you took the x-axis and just scooched it up a little bit. So your ghost shape, your like reflection is going to look like this. Outside circle goes like all the way to the edges. The inside one just touches the inside graph. So this would be like, do you see how the outside is flat again? Like the one I related to a swimming pool. This looks like a drinking glass, but the inside of the drinking glass is like this. So it's like a really weird cup. Do you get what I'm saying? It would be like that. Like you could pour water into it. It's not solid the whole way through, but the inside is like a little weird. All right, so set it up blank. Pi r squared minus r squared dx. Now this equation was set up to do a dy problem. We're going to have to actually stop what we're doing at a certain point here and go back and rearrange it so we can make it a dx problem. But let's get our boundaries first. Look at your x-axis. It won't be 0 to 2 anymore. Yeah, 0 to 4. Good job. Now let's go back and rearrange that equation all the way back to the beginning here. I need to get y by itself. Yeah, so square root of x is our equation, square root of x. So this time it's gonna be upper minus lower. Don't use the ghost shape, use the one that's actually there. Oh, actually, that's just how far to get to the outside. It's just a number. 2, like your outer radius is 2. And then the inner one is upper minus lower. So the upper one is 2, that's your axis of revolution. So 2 minus square root of x. Good, you guys are getting it. Nice. So it's upper minus lower. There's a lot of 2's in that one.